We're still working on investigating different features you can enable in Klipper firmware, and this time it'll be all about sensorless homing. Hello everyone, Chris here. Yes, we're going to continue on with our Klipper series where we take a bit of a deeper dive on a lot of the features that we've implemented already, but maybe we glossed over them. And we're going to dedicate a video to all those. This time it's going to be sensorless homing. But what is sensorless homing? Well, there's no place like home on a 3D printer, and usually we would use something like an end-stop or a sensor, move the tool head to that location, and once that sensor or switch has been tripped, that would be 0. Then your printer can proceed from there, doing whatever it needs to do. But it always knows where home is. A lot of the drivers now support something called sensorless homing. Basically, that driver can give feedback to the firmware, and once it collides with something, it knows where home is. So you're moving your tool head all the way to the end of the axis, it stops, that's 0, now you're at home. But there's a lot of ins and outs to sensorless homing, and you have to set it up specifically in Klipper a certain way. It's not hard to do, but you have to know how to do it. So that's what we're going to do. I'll run you through all the steps how to get it set up, all the features you need to implement to get it to work correctly, and give you some advice if yours isn't working correctly, and to increase its accuracy. So let's get started by taking a look at some of the hardware we're going to use. First up, sensorless homing is all about the stepper driver and if it supports it. The most common hobby-based driver you're going to see sensorless homing on nowadays is probably the TMC 2209. These are made by Trinamic. Trinamic was the one that implemented sensorless homing with a feature they call stall guard. Basically, what stall guard does is tries to prevent the stepper motor from losing steps when a set load value is reached. That's why we can use it for sensorless homing. When you get to the end of the axis, the load gets high, whatever we set the threshold at, then it stops, then we mark that as home. You will need stall guard to use sensorless homing. It is supported by several Trinamic drivers nowadays. Again, probably the most common is the 2209 right here. This one's from Big Tree Tech. But any 2209 should have that feature, as well as the 2130, the 2660, and the 5160. So here's a look at a Big Tree Tech Octopus board. Now you're going to want to make sure that your driver is set up correctly before you plug it in. There's different modes that these will support depending on the driver you're going to use. Today we're using the 2209. It is a UART mode driver, so I have the jumper set correctly. A lot of the other drivers that support stall guard or sensorless homing, they're going to be SPI interfaces, so you're going to have to add more jumpers here. But 2209 and 2226, you should be good with UART mode. Then you can go ahead and plug your driver in. Now, to utilize sensorless homing and the stall guard feature, you're going to have to get information to the diag pin here on the driver. Now, back in the day, some of these boards, you would have to clip pins, so you didn't use sensorless homing. There were things you have to do to be able to use it. Now we're back to using that jumper cap, which is much more convenient. On the Octopus board, all these jumper caps are right down here. And it's important to note that. So anything that you want to use sensorless homing on, you're going to have to cap these pins. So let's just say we're going to use it on our x-axis. This is diag 0. So we've capped diag 0. That directly links the end stop pin, the signal pin for diag 0, so your X end stop pin, to the diag pin on this driver. So now you're not receiving information from that sensor, you're receiving it from the encoding on the driver via that diag pin. That's all it does is make that bridge happen, so you're no longer using this pin for input. You can't use this pin for anything else when this pin is on. You are using this same pin, and you'll see that more in the firmware. I just wanted to make sure you knew that. That pin will be out of commission because you are technically still using it for input. It's just coming from the driver now. And that brings us to our SK Go printer. We've used it on a lot of our videos recently for our Klipper install. It has a MakerBase MKS skipper board on it. We are using Trinamic 2209s, they're just MKS branded, but it's the same chip, it still has stall guard. All of these are set to UART mode so you can communicate with the board. It is important to note you have to have a board that's integrated with these features, whether it be the diag pin for sensorless homing or the UART communication. Most boards have these nowadays, it's integrated on the board. If you don't, if you have an older board, you would have to set up some jumper wires from the top of the chip over to some open pins, it's very messy. If you're going to do this, it's much easier to have a board that has it already integrated. But we have the same situation here. We've got diag pins. We need to make sure our in-stop pins are routed to that driver pin so we can get the feedback correctly. And it's the same kind of situation that we saw on the Octopus board. We have our caps installed on the 0 and 1 diag pins. That's X and Y, because that's what we're going to use for sensorless homing. We want to not use those in-stop pins. We're going to have the driver do the work for us. And that's the first bit of information that you're going to need before we get started configuring Klipper to use sensorless homing. You need to know what pins are being utilized. The most common setup, we'd be using X and Y for sensorless homing, so we don't have to have in-stop sensors of any type. The actual physical pins for those in-stops are right here, X and Y. Again, the diag pins are located here, but then you get the pin numbers up here. So X negative, the minimum in-stop pin, is PA14, and Y is PA15. Like I said before, you have your diag pins. All that jumper is doing when you put it on is getting the info that the diag pin on the driver is sending out, X and Y, and getting it over to the in-stop pin so that we can let it tell us when that pin has been triggered. That's all it is. So these are the two values we'll use in our configuration. So if you have one of the newer integrated boards like I show here, that you're able to talk to the driver directly with the driver pins and that diag pin setting, it's not very hard to get the hardware portion set up. Just remove your in-stops, then we can move to the firmware config. Now if you have one of the older school boards, you could still do this, but you would have to jump from the driver to the board on some open pins and then configure it that way to be able to talk back and forth with that driver to get the feedback. It's pretty messy. A lot of the newer boards nowadays, the last couple of years, they already come with all this integration. I highly recommend you go with one of those boards over one of the older ones. But if you haven't, go ahead and give it a try if you're feeling adventurous. So now on to the firmware setup. So before we get started in the config, note that our SK-Go printer is Core XY, meaning you have two really long belts that do the movements for you. It's not just X and Y back and forth. You have an A and a B motor, and both of those might be turning at the same time to achieve a certain direction. That can be somewhat confusing because with sensorless homing, you're thinking that it's sensing each motor to get it to stop, when both of those motors could be turning to get it to move a certain direction. It works on Core XY just fine, but you have to follow a couple rules. The biggest one being you only want to home one axis at a time. So whatever motors that are moving, that driver is the one that it's going to sense the threshold on. When it stops, then you'll trigger sensorless homing. It will move to the next axis for Y. So even though multiple motors might be turning, it's only reading the threshold on one driver. Hopefully that makes sense. But again, it works just fine on Core XY, and I'll show you how to get it set up. So here we are back in Fluid. We need to edit our printer.cfg file. I already have sensorless homing set up on this printer, so I'm going to use the default file that the Skipper board comes with. It's for a Voron 2.4 config, but it's not going to matter for this video. I'm just going to show you how to alter that configuration to get the sensorless homing part set up. So we'll jump into that file. And most of the time, probably at the very top of your config file is going to be your stepper X and stepper Y sections. We want to start here. Now remember, I am assuming that your printer already works. You just want to implement the sensorless homing feature. Everything else should be running as expected before you start something like this. But the first item we're interested in here is that in-stop pin. I showed you on the pinout before. We still want to use that PA14 as the pin, but this is expecting a virtual in-stop now that we're going to use sensorless homing in its place. So we're going to use in-stop pin, but now we're going to point it at TMC2209 underscore stepper underscore X colon virtual underscore in-stop. With that changed, now the firmware will know that we're getting ready to use this driver feature instead of a physical in-stop switch or sensor. That's really the only thing you need to update in the stepper X section. We will talk about homing speed a little bit more here in a moment. But we need to make the same change in the Y stepper section. So I'm just going to copy this. Remember those pin numbers though. PA14 and then PA15 down here on Y. We're just going to paste that in here to make it say the same thing. And then we'll just change X to Y. Now we're going to move on down to the driver section where we actually set up the TMC2209. Here's our general config. Again, we're only interested in X and Y because that's where we're implementing sensorless homing. All of this works, we just want to add that feature. And as far as stealth chop and spread cycle goes, both of these features work just fine with sensorless homing. I've used them successfully. You will see some information on hold current. You might want to turn this off if you're using sensorless homing in certain scenarios. I usually leave it on half like it is right here. I don't have any issues, but if you would like to increase accuracy, you might consider turning it off. We'll touch a little bit more on macros you can use to increase the accuracy of sensorless homing, but let's just go ahead and continue to get it set up. So since we already have a 2209 config, we just need to add a couple of things here. The first one being, where is our diag pin? Where have we sent this information from the driver to so that we know when the axis has been hit? So we want to do a diag pin, underscore pin, colon, and then we give it that in-stop pin number that we just overtyped above. So for X, it was PA14. Then we have to set the sensitivity threshold for stall guard. We have to give it a number so it knows how sensitive this driver motor combo is going to be, so it knows when to stop the motor. If it's set too high, the motor will just continue to run and drive that tool head into the carriage. If it's set too low, it won't move at all because it'll always be triggered. So with a 2209, it's a little different with different models, but we're going to do driver underscore in caps SG for stall guard, and then THRS for threshold. And we'll do a colon, and I'm going to start with 100. We'll talk more about that in a second. It's also probably worth your time because not every driver is set the same way. For a 2209, leave yourself a note. So do a pound sign and then put in something like this. The highest value for this sensitivity is 255. That is the most sensitive. So if it was set to 255, the axis probably wouldn't move at all. It's going to be triggered all the time. 0 is the least sensitive. So if it was set to 0, it would never stop. It would just continue running that motor into the side of the printer. So it's good to have a note in here if you ever need to adjust it so you know which way to go. So now we know for our driver where we're getting our information from our pin and our starting sensitivity. And then we'll come down to the Y stepper. We're going to do the same thing on a different pin. So diag underscore pin. We'll use that Y end stop pin, which was PA15. And again, we will set our threshold. Driver underscore SG THRS colon, and we'll go with 100. Again, I like to leave this comment in here so I know if I come back later how it's going to be set. And that's all you need to do to get you started. But now we need to dial it in. So now we're back to my actual printer.cfg file so we can start tuning things in. Now, if you're having problems with sensorless homing, mine actually works in this configuration right here. I haven't changed anything else. But if you're having issues or you need to increase accuracy, the first thing you want to tackle is homing speed. You don't want to go too slow because it's not going to be able to handle that either. But you definitely don't want to go too fast. A good rule to follow with homing speed and sensorless homing is half of what your rotation distance is. I'm using a different size pulley, so mine is set to 32, but most commonly it's probably going to be set to 40. So homing speed, start with a 20 for X and Y. That might get you where you need to go. Now, remember, if you change speed or your feed rate of how you home, your threshold might change. So keep that in mind. If you adjust one of these, speed or threshold, the other one might need to be adjusted as well. So we'll go ahead and save and restart. The good news is we can set that threshold without having to come in here into the configuration. We can just do it with a console command until we're happy with the value. So we'll save and restart, and then we'll go into that. So with the configuration changes we've already made here, I'm just going to go ahead and try homing to show you what to do if you need to troubleshoot this. I'm just going to hit the Home All button here, but let's take a look at the printer first. The biggest thing you want to avoid is crashing tool heads. You don't want to break anything while you're trying to set this up. So manually move your tool head somewhere in a safe location, because remember, we're going to try to home. Wherever your home location might be, mine's here in the upper left. We want to get close to that, but it might not be able to do that first time out until we get the threshold set correctly. And something to note, mine does Z-Safe Home. So if there is an issue where it triggers before it should, it's still going to try to go to the center of the bed to home Z. And we don't want it to be somewhere out here, then try to go to the center and crash here in the back. So for each test, I'm going to be up here just because I know it's going to move half of the bed to home that Z, and this should keep us out of trouble. But let's go ahead and do that home all now. So you can see it barely moved X and Y, and stall guard was automatically triggered. So the sensitivity is way too sensitive. And again, the easiest way to dial this in is via the console, so we don't have to edit that configuration each time. I've done the command a couple of times, but we'll pull it in down here so I can show you. We're going to work on this one axis at a time until we're satisfied with our threshold. But you're running the command set_TMC_field space stepper equals stepper underscore whichever one we're working on. We'll start with X. Then you want space field equals SG threshold, stall guard threshold. Remember 2209, this is what you want to use. Other drivers, that field might be a little different. And then we currently have our sensitivity value set to 100. Remember, I made you make that note in the configuration file. 255 is the most sensitive, 0 is the least. So 100 is too sensitive for our axes. So let's just jump down to 90. And we'll send that command. Now what I recommend you do is do motors off. So that resets everything, and we're just working on X right now. So we'll put our axes somewhere in the center to avoid crashing. Since I know we're just going to move X this time, we don't have to worry about Z-Safe homing, but I'll just hit the X home button. We lowered Z, and again, we moved just a little bit, and it triggered. So we're still too sensitive. So we'll bring that console command back up. Let's set it to 80. We'll home X again. Still too sensitive. With a little bit of trial and error, I've brought it down to a value of 60. Again, make sure your carriage is out of harm's way, and then we'll go ahead and home X one more time. Now we're starting to move towards 0, very slowly. Again, that slow movement does help accuracy. And it stops. Now, if you were to hear grinding, it's probably not sensitive enough, but this seems to be a good setting. Now, you want to try this multiple times. Make sure that you're set at a comfortable setting where it doesn't grind at all, but it also sets consistently. So when you head towards the axis multiple times, maybe move the tool head around to different Y positions. Make sure all of them are consistent, and you're going to get a consistent reading every time you home. Then after you're happy with X, we can move on to Y. Now that we know X is setting around a 60, Y is not necessarily going to be the same setting, because the different mass, it's a different motor, things are going to be different. Even though it's Core XY and they work together, it's going to be a different setting more than likely. But we know that 100 is probably too high in this configuration. So back to the console, we'll just change stepper X over to stepper Y. And let's just set it down to 60 for a starting value. Then we'll go back and just home Y. Again, the tool head and the carriage out of harm's way. And we're starting to move towards the front. And it did stop, but I did notice it hit pretty hard. So that tells me the motor actually tried to move it just a little bit after it stopped to get it to read high enough to trigger that feature. So in that case, I would want it to be just a little bit more sensitive. So we'll go ahead and move back to the center. We're setting at a 60. We want to add just a little bit more sensitivity. Let's try a 65. And we'll home Y again. That time, Y didn't move at all. So it's a little too sensitive. And now you see how hard it can be to dial these in to where you want that accuracy to be. So back to the console. We'll try somewhere in the neighborhood of 62. And after a little bit of trial and error, I set around a 62 for my Y for the sensitivity. But it's important to note that the speed, all these different settings are going to matter, as well as where the carriage is when the other carriage is moving. And that might seem kind of crazy, but I would recommend you always home in the same order. So do X first. That way, when you go to do Y, especially on a Core XY machine like this, the mass is going to be in the same location for that tool head. Then the sensorless homing should act more accordingly when it moves that Y bar up. That's just been my experience, but I would keep it as consistent as possible to increase your chances of accuracy on sensorless homing. And just to give you more information, the current and the hold current are going to matter, like I said before. If you're having issues, definitely consider turning hold current off or setting it somewhere in a macro so at least it's not on before you try to home. Also, back up in the stepper driver section, you have to make sure that your home retraction distance is set to 0 for both X and Y. This is when you go check the end stop, you come back from the end stop a little bit, maybe 5 millimeters, and then you check it again. You don't want to double check sensorless homing. That's just going to confuse things. So just check it once. You can do that by setting this setting to 0. So there's the basics to sensorless homing. And it does really simplify your printer configuration. You don't have to run the end stop wires. It just makes things a lot cleaner. But in my opinion, it's never going to be as accurate as an end stop switch or some kind of sensor would be. The consistency just isn't there. In fact, even something as simple as a little piece of stray filament on your linear rail could trigger sensorless homing inadvertently and cause big problems. Because if you were to start a print after it thinks it's home, you could cause some crashing. Now with that, I run it on lots of different machines with no problem at all, but you need to consider things like power loss recovery. If you didn't get a good XY home at 0, 0 and you hit something like power loss, how are you going to be able to get back to where you need to after you recover if you don't know where a good home is? So keep all of that in mind. It's a really cool feature. I really like using it, but it might not be the best one in certain scenarios. You can improve its accuracy by doing several things that I mentioned before, as well as a few other things. So let's take a look at that now. So we mentioned the big things. You want to make sure your retractions distance is set to 0 so you don't have any. You want to be pretty responsible with your homing speed. You don't want to go too slow, but if you slow down a bit, it's going to be more accurate. And of course, make sure you have your sensitivity dialed in. Now, there are some suggestions made by folks that if you do home with sensorless homing, you go to your stop point and then you actually back up a bit to make sure the bits have been flipped correctly, so when you go to home the next time, they're ready to do so, so you don't get inaccurate readings. And the easiest way to do something like that would be in a macro. So if you want to try some scenarios like that to try to get sensorless homing more accurate, I suggest you do it in start print. That way it runs every time you start a print. That should be in your slicer to run that macro first. So I have mine in printer.cfg. I have mine called print start. You can call it whatever you want, just as long as you have it in the slicer to run it before each print. Right now, you can see I'm just homing Y, X, and Z to 0 with a G28 command. If you wanted to increase your sensorless homing accuracy, you might do something like this. We'll just comment out our current home command, and since we have Z-safe homing, we really have to do X and Y first. But we'll enter a G90. That will set the machine to absolute positioning. So it positions based on the whole axis. So it assumes from 0. Then we'll go ahead and let it do a G28. But we'll do X first. So X0. And then after we've homed X, we'll move away from the carriage just a bit. So we'll do G1, X5 at a fairly slow feed rate. So we'll do F1200. This will ensure that the X-axis isn't pressed up against the side of the carriage, which could skew your results. Again, these are just accuracy tips here. We also don't want to go ahead and home Y too quickly, because that could skew it as well. So we're going to give it a G4, that's the wait command, and we'll do P2000, so 2 seconds. That's enough to make sure that the stall flag has been cleared. If the motor doesn't move, it's going to clear the flag. Then we'll go ahead and let it do Y. G28, Y0, and move back 5 millimeters. G1, X5, feed rate 1200. And we'll go ahead and wait 2 more seconds. G4, P2000. That's just a little safer way to home. Then, since we're not using stall guard or sensorless homing on Z, you can do G28. Z. 0. So now, even if your printer or your slicer has entered a homing command, we've run through the sequence before we started the print to make sure sensorless homing is as accurate as possible. And you might think moving to X5 or Y5, I need to change this one to Y, that might skew where your print head is, but because we've switched to absolute with our G90, it's just moving to 5. It knows where 0 is. It's not going to skew anything else. It's just setting at 5, waiting for the print to start. So when you've tuned in sensorless homing, you found the thresholds that you like. We went with around 60 for both Y and X, a little bit less for Y, but you get the gist. We were around this number on these settings. Put in your settings, make sure you save and restart, and depending what you have on your print start macro, you could probably just run it. If you're doing something very creative, you're heating up different things, you might not want to run it, but just to go ahead and test it, we'll run it here without a print actually starting. We'll kick off our print start macro. We're going to home X. Then move back a bit. Then we'll start to home Y. And move back a bit. Then it'll continue on to save home Z. This should give you much better results and consistency than just setting it up without tweaking any of these settings. But remember, you do have to run that print start macro before every print to make this happen. So there you go, sensorless homing in Klipper firmware. Hopefully there's some tips and tricks in here that help you get it set up and to increase its accuracy. Now, I don't feel that it will ever be as accurate as an end-stop switch or a sensor of some type, depending on its quality, but I do use it on a lot of different machines and it works really well. But remember, if the axis does stop for any reason, it could think that was home and cause some issues when it goes to start the print. So I would definitely keep an eye on it every time I started a new print, or at least until you get that first layer down. Then you're probably all set. And it might affect features like power loss recovery if it can't get back to that accurate home position when it comes back up. So all these things you need to keep in mind if you want to use this feature. So hopefully you found this helpful. That is it for today, and I'll see you really soon on the next one.